Okay, so in this experiment 3, I am aware that some of you managed to get the data for both the parts, and some of you have got wrong data. I have seen your records. Some of you have got the right data, and some of you have not managed to get the data. Okay, 3 possible groups of students are there. So now what I am suggesting is, I have done the experiment carefully and I have the data also, which is correct. So for now I will share that data with you. So those who have managed to get the correct data, use your data with the method I am explaining to complete your result. Those who got wrong data or those who did not get data, use my data to finish the report. Okay, please listen to my instructions. I am telling you clearly what you should do. So follow it. Afterwards you can ask questions. So those who got the correct data, you will know when I describe the graph, if it follows the same thing. Use your own data. Those who got the wrong data, you will know it's wrong because it doesn't follow the trend of the graph. Then discard your data, use the data which I will be mailing to you. And those who have not managed to collect the data, also use my data which I am mailing to you. Now, next lab class we will do a new experiment, but all the experiments are based on the same thing: current, electric current, cell, resistance, potentiometer, same things in different ways we will be doing. Okay, so when we do the new experiment on the next lab class, after finishing that, if you have leftover time, you can repeat this experiment for yourself. That is option 1. Second option is, any day after the 8th school, you can come back here. The lab is open till 4:30. Get the same apparatus, do it yourself and check it for yourself. Ultimately, each one has to take the responsibility to know how to do the experiment and get the proper graph. So individually you have to do and see for yourself till you get the proper graph. Okay? But I can't keep giving lab class for that. You have to practice individually after the 8th school, any day of the week. Okay? What question you have till now based on what I said? No, right? Let me explain. Everything I'll explain. What?
Haven't done VD in part B.
Watch this.
VD is this.
The external.
I'll explain this diagram. Don't ask anything about diagram.
Before you move on,
Yeah.
you collect your own data again.
You can collect it after 8th school, not in the regular class.
Double school में नहीं कर पाएंगे.
Double school में new experiment करना है. See, I'll tell you the problem. We have around 12 prescribed practicals, and I need to give you practice from past paper experiments also.
Yes, sir.
So the more you practice, the better for you. So if I keep repeating the same experiment 2-3 weeks, no, then you won't get enough time to practice. Then you will be in danger. So just come after 8th school. Now let me explain this. The theory required also I'm explaining. What?
Just click a picture right as the.
I will send everything, don't worry. Okay, now listen carefully please. Because once you understand this theory, all the current electricity experiments will be in your grasp. Are you getting it? The same theory applies in every current and electricity experiment. So make sure you understand what is happening. Okay, see here. This is the tri-cell. This dotted box is a tri. Please, let me explain. I didn't even start. Okay, what is your question?
My question is, will you teach this again when we do the chapter, or is this the first and last week teaching this?
What will I teach?
Theory you're teaching. Is this the first and last week you're doing it, or will we teach it again? Will we do it again?
Current electricity, when I do it in theory, again I will teach. Don't worry.
That's
Pay
good.
attention, mind.
Okay. So now this dotted rectangle is the tri-cell, the boundary of the tri-cell. Okay. Now we are going to split it into 2 parts: the EMF part of the cell and the internal resistance of the cell. And in this circuit, current comes out of the positive terminal
Okay.
and enters back into the negative terminal. So this end of the cell is the higher potential. The positive terminal of the cell is the higher potential. Negative terminal of the cell is the lower potential. Agreed?
Yeah.
So now when you connect a voltmeter across this cell, okay? When you connect a voltmeter across the cell, the voltmeter gives you the difference between the high potential and low potential points. So it gives you VB minus VA. So always understand when you measure voltage, what is it measuring? It is measuring the difference in potential between this point and this point. The edge of the cell here and the edge of the cell here. And inside this cell there is an internal resistance small r. Sanidhya, your mind is not here. Then in the end you won't understand. Focus. So this voltmeter is measuring VB minus VA. So we need to know what exactly is that. So to do that, we will use Kirchhoff's voltage loop rule, which just says that the sum of changes in voltage or potential as you go along a loop is equal to 0 for a closed loop. Now what we'll do is we'll apply it in a certain way. See, like this. If you start from point A, at point A what is the potential? VA. So you start with the potential of VA and then you go through this. So U meaning the positive test charge. If a positive test charge goes through a cell from negative to positive terminal, the potential will rise. If a mass m goes up the hill from a ground level to higher top of the hill, its potential energy will increase. Potential will increase by GH. Like that, if a positive charge goes from negative terminal to positive terminal, its electric potential will increase. Agreed? Kunal? So it will, from VA, the potential has increased by plus E. And then when it goes in the direction of current, current always flows from high potential to low potential. That means it has gone towards a lower potential. So the positive charge has lost potential in going in the direction of current. So whenever the positive discharge moves in the direction of current, it means that the potential is falling. This is a way to bang the door and enter. What?
This is what I am told to do.
Bang the door and enter.
Sir, do you want him in class?
Sit quietly without disturbing. I don't mind. So the potential drops. Agreed? Yes. You have a question?
Is electromotive force type of voltage?
Yes. EMF, it's called force, but it is not a force. It's a potential difference. It is the potential energy given to a charge
It's basically the
to
energy.
complete the loop.
It's basically the energy to.
Energy per unit charge. It's same as potential.
Like it's the voltage to bring a charge from low potential to high potential.
EMF is the total energy required for a positive charge to complete one loop. Okay? Some of that energy is lost inside the cell itself when it crosses the internal resistance. So the leftover energy is available for our use.
So this is only for the internal part of the cell, right?
Yes, right now I am discussing about the internal cell.
So sir,
Wait, let me finish, then I'll take it again. I'll take the questions in the end. Listen fully to the whole story. So from point A, VA plus E, and then in the direction of current when I go, the potential drops, so it becomes minus IR. And you have reached point B. So what is the current potential right now? Whatever is the potential at B, because right now you are at point B. Agreed? Yashasvi, are you following?
Yeah.
So this equation makes sense. Agreed? We started from here, increased, then decreased, finally you reached at B. So the current potential is VB. Now the voltmeter measures VB minus VA. So from this equation, find out VB minus VA. So VB minus VA is E minus
IR
IR.
minus ER.
And this is the.
VB minus VA. This VA goes to this side. This VA goes to this side.
Got it.
So VB minus VA is equal to E minus IR. Agreed? Now, we are measuring this VB minus VA as VD. So VD is equal to E minus IR. Agreed? So now we are plotting a graph between VD on the y-axis and I on the x-axis. So now compare it with the straight line equation. What do you get? VD is your y, I is the x, m is minus r. So slope is supposed to be negative, and y-intercept will be the EMF of the cell. Do you get it? The y-intercept is EMF because I current is x and the slope m is minus r. Look at this. So you will get a negative slope graph like this. Wherever this base fit straight line will cut the y-axis, that should give you the EMF value. So from your graph, find out the y-intercept, note down the EMF value on the graph sheet.
So when.
So
when current is flowing through a battery, EMF is more than the voltage of the battery.
Yes, the terminal voltage is lesser than the EMF of the cell when the battery is discharging.
So B form electricity.
Yes.
A form the formula.
ये फॉर्म में किया था तुम लोगों ने? Yes. So this is actually terminal voltage. VB is actually the terminal voltage. It is always less than the EMF when the battery is discharging. Sanidhya, bag under the table please.
So why does the battery get discharged? Like when EMF finishes?
What?
Why does the battery get discharged?
Discharging is the name given to the process when the battery produces current.
So why does it get discharged?
Why does the battery produce current?
Why does it get discharged? Like
Discharging means if you connect the terminals of the battery, current will flow or not? What is the question?
but batteries die out, actually. Batteries die out.
That's because the chemicals get finished.
That's what it is.
and
Chemicals are doing the job of. See, you are going into the details of how the battery works. That is not our priority now. That will take later. Okay, we have to finish this
will
experiment.
we do that?
Yes. How the battery works is a different question. Now stick to this. This you understood. So the first from the graph one you will find out the EMF of the cell and internal resistance of the cell. So your result will have one part like this. Understood this?
Yes.
Everyone? Now for part B. In part, everything clear right now, right? Till now?
Yes, sir.
Now for part B. Now what we have done is the same old circuit we have, but we have added one bigger voltage battery opposite direction to the previous battery. So this was a dry cell, this is a battery accumulator. You will set it to say 8 volt. This is around 3 volt because you have two 1.5 volt cells. This is 8 volt. So this will dominate. See, this is trying to push current like this. This is trying to push current like this. So whichever is creating greater push, the current will flow in that direction. So this direction current will flow. Agreed? So when current flows like this is higher potential, this is lower potential. And the voltmeter is measuring higher potential minus lower potential. So the terminals of the voltmeter also you can mark it. So here also the terminal of voltmeter will be plus and minus here. What? Part A, part B is for the same experiment. Experiment number 3. Yes. Okay. So now, so again, yes, yeah. What? The question. So now current is flowing like this, and this voltmeter is measuring VB minus VA. So again, we want to know what exactly is it measuring, right? So if it's measuring VB minus VA, so let us start from the point B, okay? And let's imagine a positive discharge is going from point B towards A. So at B, whatever is the potential, we call it VB. In the direction of current, if the discharge moves, its potential will decrease. So minus IR, where R is internal resistance. And then it is decreasing, it is going from high potential to low potential of the battery. So minus EMF.
But if the terminal the opposite side is plus here.
Yes.
नहीं समझा.
Now the positive discharge is going from high potential to low potential, like going downhill. From top of the hill, if it goes down to the hill, the potential will fall. Huh? Yes. In the first case, we are going from low to high. So potential increased. It's like climbing a hill. Now it is climbing down a hill. Getting it? So potential of the discharge will fall by EMF. So VB minus IR minus EMF, and you reach the point A. So now you will reach the potential value will become equal to the potential at A. Ananya, is it clear? Everything? So if this is the equation, and if the voltmeter is measuring VB minus A, Rana, mind should be here. So voltmeter is measuring VD, which is VB minus A. So which will be EMF plus IR. So you see the difference. Here it was measuring EMF minus IR because the battery was discharging. But now a powerful battery outside is driving current into the battery in the opposite direction. So this is like charging.
So will the battery
This corresponds to a case where a battery is charging. The direction of current is in the reverse.
this is how we recharge a battery.
Yes. When you recharge a battery, you force current into the cell. When a cell discharges, current comes out of the cell.
So, but there's some batteries that don't get recharged.
Yeah. So in this case, you are forcing the current into the cell. Yes.
Sir, in the graph,
What?
Why does that happen? Like
It
somebody.
is happening because this is 8 volt, this is 3 volt. What other option is it having? If you have two pumps, one is pushing with 100 Newton, another is pushing with 5 Newton. Water will move in the direction in which 100 Newton force is acting, right? Same thing. Yes.
so in the graph, Y is the voltage and X is current.
Yes.
How does the current vary in the circuit? How the
Current is varying because we are changing the rheostat resistance.
Only during the resistance the current varies. Everywhere else is similar.
Yes. See, listen. Current cannot change from place to place in a series.
Exactly.
So, for one value of rheostat position, there will be one value of current, there will be one value of PD. So, I start my experiment with rheostat at maximum resistance. Okay?
So, but at two different points of the circuit, current will be the same.
No, two different points in the circuit, current will be the same.
Yeah.
Two different positions of rheostat, current will be different.
Yeah. So we're only talking about the rheostat, not the whole circuit.
Listen, for each data point here,
Okay.
I have to move the rheostat position to a different value. So this data point corresponds to rheostat position at one value. This data point I got by moving the rheostat to new value. So from maximum resistance to minimum resistance, I will keep it at 5 different positions. So I will get 5 data points.
And I got confused. I thought circuit.
Okay. So Vd is actually E plus IR. Now compare this with the y equal to mx plus c. So now listen students, in your lab record, Yashasvi Siddharth, in your lab record, you have to write only this much. Nothing more. You have to write only this much. So take your lab record right now. I will mail you the data points right now. You can finish your record right now if you do not have your data.
We have a data
and it corresponds to that.
So you just need to write this much in your record, nothing more. Just write the final result, put these graphs on the left hand side, circle
that
them on.
EMF in both the graph will be same now.
It should be ideally same, but it will not be same. It will be close to each other.
And even
for me it was not same.
Even the internal resistance should be same.
Should be same, but it won't be same.
No, ideally it should be same.
Ideally. Even for me it's not same. So the intercept is again going to be EMF, slope is going to be internal resistance. So again do the graph, now you will get a positive slope, now you understand the meaning of y-intercept, positive slope, everything. So write your result like this. So now I will share the data with you. Yes, any questions?
So please upload this.
Yeah, I'll upload. Any questions?
तो लैपटॉप यूज करने में चेक करने के लिए
Right. I'll show the data on. Can you erase this?
तो मेल कर दूंगा
Copy it. No. Copy it and then I'll share the data on this.
You mailing it now?
Don't open laptop now.
So should
I will present it on the screen. No, wait, I'll be explaining the data also.
One simple one.
If you have a positive trend, for this is part 2. Part 2 as current increases, voltage should increase. So opposite. As current increases, voltage should increase. But what will you do with 1/2 data pressure? You should use both of same type. No? So use my data. I will write it on the screen. Okay? Yes. For this one, this should show reverse trend. If voltage increases, current should increase. Yeah, this is correct. Yes. Okay.
The cell is recharging.
What?
The second part is doing
My name is
higher
Gyaneshwaran.
low potential cells
I am
and
not ignorant.
No, you can't say that it's actually recharging. Okay. What is happening is no. What is happening is current is going in the opposite direction inside the cell. That's all. Only for rechargeable batteries, the cell will be recharging because the chemical reaction will go in reverse direction.
for rechargeable batteries also. Ideally also everything
Yeah.
but then
So here, this is the higher potential. No, this is dominating over this.
I think I need
This is a much higher potential than this. So it go compared to this is lower potential. This is 3 volt, this is 8 volt. No, here it's going from higher to lower. All these are lower than this. This is plus 3, this is 0, this is plus 8.
But I am just like voltage.
Clear?
So much that
So keep the record before it's a potential we can finish. This is all I know. Before the today. Students, see the deadlines are given. Please respect the deadline. If you can't give on the deadline, give before it, not after. You adjust your schedules accordingly. I cannot make changes for everybody. Mind meeting goes and then do this data accordingly. Please. Okay, I'm erasing this. I will show you the data.
This is fire voice. Fire is talking gas, not anything.
So you have basically 12 experiments which are prescribed, 6 from light, 6 from current electricity. They are all of manipulations of the same concept. So once you understand the concept thoroughly for one experiment, all the other 5 experiments will be easy for you. Yeah, this I will be mailing it to you, don't worry, but now we copy it and finish your record. These are the 2 tables. So after the experiment, when you are free, come and do the experiment to make sure you get the data correctly. One main source of error or problem is if one of the connections are loose, then it won't work. Make sure all the connections are very tight. So have you copied the data? Copy it fast. Just these 2 columns of data. Part 2, part 1. Copy it quickly, Then I will show you the logger plots also. The same way you have to plot in your graph sheet. You can collect the graph sheet from lab assistant. Use this time to finish up your record and submit it.
So,
Yes. You take it.
Yeah, so we don't have a record.
Yeah. Record is here.
So I took it yesterday.
The Vijay has
Keshav, finish lab experiment 3. Anush, just distribute it. No? Okay. I'll just quickly show you the logger record also. See here. This is the graph 1. This is the graph 1. वैल्यूज कितनी देर नोट करोगे यार, मैं फिर से दिखाता हूँ. अभी ग्राफ देख लो, फिर से दिखाता हूँ वैल्यूज. पार्ट ए का ग्राफ ऐसा है, नेगेटिव स्लोप. You extend it to cut it y-axis. This turns out to be 2.5 volts EMF, and the slope is 2.1 ohms in the part E. Okay. Now part B, you see.
सर पेन है क्या सर आपके पास? सर do you have a pen, sir?
No. Yeah.
देख दो. So you're giving diet?
What?
Iron.
Now क्या हो?
Sir, give me Alex. Sir, give me Alex.
This is the part B graph. So again you can see this time the slope is positive and the y-intercept is 2.8 volts. Okay? Y-intercept is 2.8 volt, the slope is 1.9 ohms. So it's different, but close. So this is a typical data you will get. Yeah, these are the values of part B. You can copy it down. 0.3, 0.4, 0.5, 0.71. जल्दी से लिख लो. Okay, you can stop the recording.
Anush,
So you can